In this quick video, I'll show you how to maximize area functions. The question reads, Mark has 100 feet of fencing available to build a rectangular pen for his hens and roosters. He wants to separate the hens and roosters by dividing the pen into two equal areas. What should the length of the center partition be in order to maximize the area? What is the maximum area? So we have 100 feet of material, and we want the two areas to be the exact same. Let's begin by drawing out a rectangle. A rectangle should look something like this. We want two partitions, one for hens and one for roosters, and they need to be equal area. So I'll place a line in between. It's not to scale, but you get the idea. Now, we'll call this length x, that length x, and that x. We'll call these two lines y, x and y. So the area here and the area here have to be the same. The perimeter will equal to 100 because that's how much material we have. The perimeter is the distance around the shape, including this fence. So the perimeter will be 100 is equal to the sum of the two y's, so y plus x plus x plus x, and we'll combine these terms into 2y plus 3x. That right there represents the perimeter. Now, let's put this in terms of x. So we'll solve for y. I will bring that over. We have 100 minus 3x is equal to 2y, and I'll divide both sides by 2. If you do that correctly, you should end up with y is equal to, or the length of y is equal to, negative 1.5x plus 50. Notice that I rearranged these two terms, and I made 3 over 2 as 1.5, which is what it's equivalent to. Now, for the areas. We have the area of this whole rectangle can be represented as area is equal to the length times the width. So the length will be y and the width is x. Now, to maximize the area, what I could do is substitute this value into the y. That way I have one function that I can start to maximize. I have a is equal to negative 1.5x plus 50, and that's being multiplied to x. If I expand this out, so this is where our algebra comes into play, I end up with negative 1.5x squared plus 50x. Now there is a formula that you can use to find the vertex of a parabola. Notice that this is a quadratic. We have x to the power of 2 as the highest degree. If we find the vertex, we have essentially found the turning point of the parabola. And because the term, the coefficient here, negative 1.5 is negative, the coefficient of the x squared term tells us whether the parabola opens up or down. Now, since this is negative, expect a parabola that looks like this. And if the parabola is pointing downwards, then the vertex will be a maximum. We need to find out what the point of this vertex is, the x and y coordinate of that. Now remember what they're asking. They are asking to find the length of the center partition where the area is at its maximum, and then find the maximum area. So by finding the x coordinate, we will find the length, and by finding the y coordinate, we are finding the area, because the y-axis, if we were to place this on a graph, the y-axis represents the area, and the x-axis represents the length of these partitions. To find the x of a parabola, you can use this really interesting formula where x is equal to negative b over 2a. Negative b over 2a represents, if we were to take a look at the standard form of a quadratic, ax squared plus bx plus c. A represents the coefficient of the x squared term, while b represents the coefficient of the x term. That's easy to identify. The b will be 50 and the a will be negative 1.5. If I substitute these values, I end up with negative 50 over 2 times negative 1.5, and plugging this into our calculator, we get negative 50 divided by 2 times negative 1.5, and we get 16.6 repeating. So 16.6 repeating, and that represents the x-coordinate of our vertex. That also represents the length of the x's. So this will be 16.6. Because they don't tell us how much to round, we can simply represent it as 16 and 2/3, 16 and 2/3, 16 and 2/3, because 16.6 repeating, 6 repeating is 2/3. Now, if we want to find the maximum area, all we have to do is substitute this back into this area equation that we made. So place that x into there, and we'll find the maximum area. So negative 1.5. I'm substituting that last output that my calculator gave me. So I'll click ANS squared, or you can just type in 16.6 repeating. This is easier. Plus 50 bracket, again ANS, the previous output. And we end up with an area of 416.6 repeating. So the area happens to be 416.6 repeating, or 2/3. So I'll write down 14 and 2/3. Remember the units were feet. So it should be feet squared. Now, of course, you can take this a step further. That answers both questions, but you can take this a step further and actually find out why by substituting the value of x into this equation, and you also find the length. So there you have it. That is how to maximize area functions.